If I asked you who the oldest living character with a bounty was, would you guess it'd be this guy? Or if I told you that characters with the blood type F average the highest bounty out of all characters, would I have your attention? If so, I encourage you to check out my video coming up where we use data analytics to conduct a bounty analysis. Stick around. Welcome back to the channel, YouTube. I'm Taicho, the XX, and today we're conducting a One Piece bounty analysis. So the first part of our video, we're going to start with data synthesizing, and I'm not going to spend too much time here, but we've worked pretty hard to web scrape a bunch of different One Piece fields. You can check out various videos here, and even check out my web scraping playlist where I go much more in depth on how we do that. Ultimately, what we have is now 12 to 13 different tables that you can see here, and we're going to be focusing on 4 or 5 of them for this analysis. So the first table is going to be One Piece character bios. We're going to be pulling the origin and the blood type from this field. I thought those would be interesting categorical variables to analyze in the bounty analysis. Our second table has the character age. That's a great numerical field, so of course we have to include that. Third table is going to be One Piece character heights. If you've been reading long enough, I'm sure we all understand that One Piece characters come in all different shapes, sizes, aesthetics, genders, whatever you can think of. I'm sure there's a One Piece character that has it covered, so we gotta bring in the height. Second to last, we're gonna bring in the One Piece character chapter appearances. I thought this would be a valuable field to bring in. Basically what we will do is see if character appearance patterns have any role in bounty. So for example, characters that are first introduced in East Blue will have much lower on average bounties than characters introduced in Whole Cake Island. Or so we would think. And then now, last but not least, of course, we need the One Piece character bounties. As you know, some characters will have multiple bounties, but you'll see in this next step how we'll kind of aggregate that. Cool, so here now you can see a SQL script, which essentially is what I use to synthesize all those different tables so that we can have one tabular format for the analysis. Using data terms, data analytics terms, I use what is known as common table expressions, also known as inline queries, but essentially what I first did was I aggregated the chapter appearances to give me 3 different variables. The overall count of different chapters that a character appeared in, the initial chapter that the character appeared in, and the max chapter that the character appeared in. That gives us 3 additional numerical variable fields. And then I did a little bit of cleaning for the bounties. Basically, again, we know that some characters have multiple bounties, so I wrote a query in the back end that aggregates those to give us the maximum bounty per character so that we don't have duplicate records. And which you can see right here. Right? And then lastly, we have a final select statement from our character bio table, and then 4 different left joins. If you're interested in different conditional joins, I encourage you to check out this video here, but this video I'm not going to focus too much on that. All you need to know is we have essentially 5 tables that we're using for this analysis, and of course we want to make sure that we remove any bounties that are null, and then up here any characters that have 0 bounties. What that does is that really refines the character dataset down to less than 150 characters with actual bounties. So now we're in a Jupyter notebook. First step we're going to do is some pre-processing very quickly. We're going to import all of our packages, import the data, and then let's get a quick idea of what the data shape looks like. So we see that we have 129 rows or 129 characters and 19 different columns. Let's take a peek at the data. So we see that we have link, origin, all the different columns from all the different tables essentially here. But we also, if you notice, we have some redundant columns. So what we do in the next step is really just kind of trim out the fat and BioClean. And then because I operate in the Western Hemisphere and we use the superior means of measuring, aka the metric system, I had to go up here and change the height measure, which is in centimeters, to feet. So that's what I do here, and then I also fill in some NAs. Some characters, they don't have their origin filled in, or they don't have their blood type, so I just plugged in unknown for those. And then what I also did was, for dimensionality purposes, so to say, I took their origin, and basically the way different islands were popping up, specifically for the Grand Line, or different areas, but mainly for Grand Line, it would be Grand Line and then an island. Grand Line and then island. I just made it all Grand Line. So that'll give us what I call BioClean, and then you can see here's that data. We're down from 19 columns to 11 columns, so this will be easier for us to work with, and we don't have to worry about redundant data. So the first thing we're going to do to get an idea of what's actually in this data is we're just going to run this quick clip called describe, and that'll give us some summary stats. So you can kind of see which characters I'm still missing variables for. So 14 characters I don't have their height, 19 characters I don't have their age. We'll fix that later on. You can see the average age is about 40 years old. The average number of chapters a character appears in with a bounty is 75, but that's definitely inflated by our main characters, so I would expect that to actually be much less. The average initial chapter appearance is 485, which I believe is Sabaody, and then the average chapter appearance is, max chapter appearance is 889, which should be Whole Cake Island. And then the average bounty is 596 million berries, which, if you're caught up in the context of today's story, that's pretty low. And then lastly, the average height, which is 12 feet. All these characters, they're definitely getting a lot of right swipes on Tinder. When you're 12 feet, they said forget 6, 7, 8 feet, we're going right to 12. So shout out to all those characters. Nice. So the first kind of area I wanted to poke at was kind of the heights. I just wanted to get an idea of what character, min and maxes look like. So we run that with this clip, and we have two, I think, very interesting characters. I should say interesting. We have Little Orange Jr., who had a short-lived spotlight in Marineford, coming to rescue Ace. Had Gecko Morris salivating at the lips, and that was super short-lived because Doflamingo was having none of that, slicing off his leg and all that great stuff. And then we have the lovable kawaii Tony Chopper. So to compare their heights, we can see that Little Orange Jr. is 200 feet tall, whereas Chopper is sub 3 feet tall. So that just gives you an idea of, again, all the different aesthetics that One Piece characters come in. The next thing I wanted to look at was kind of take a look at the age. So we'll do the same thing, get the min and max ages, see what those characters are. And this I found really interesting. So coming in as the oldest character at 160 years old is Morley. Definitely not something I would expect, and definitely not something that's like kind of talked about, I don't think, at all. So perhaps this means that given his age, he may have some more context to add to the story outside of his flamboyant personality. And it's especially interesting because we all know he's part of the Revolutionary Army, so a 160-year-old character has to have been around, different eras and the way that the world operates. So I found that very interesting. And then we have a very relevant character in the story right now, who is Julie Bonnie, hashtag Bonnie for Straw Hat. But yeah, she comes in at age 12. That might be a little spoiler if you're not caught up, but yeah, she is 12 years old. She appeared first at Sabaody arc. Going through a lot of characterization right now, and I think she's a really fun character. I think she fits in really great with the crew, so I wouldn't be surprised if she joins. Especially given all the other context. Nice. So that kind of gives us an idea. You know, we're working with a 12-year-old girl in one scenario. Then we have a 160-year-old flamboyant individual on one end, and then we have a 200-foot tall giant that has a bounty, and then on the other end we have a 3-foot talking reindeer. So I think that really shows the world building and breadth that One Piece instills and is known for, because none of those characters have anything in common other than that they're all pirates. Nice. So as I mentioned, there were some characters that didn't have age or height, so what I just do here is I just input the median. Usually not the best option, but because we have such few rows of data, I just thought for integrity purposes, why not just do that and keep everybody. Make sure we have no nulls so we can see that we're good. And then here's our clean data set again, which we reviewed. Yada yada yada. So now we're going to start with some data visualization. The first field that I wanted to take a look at, we're going to work at, we're going to do kind of univariate analysis and then bivariate. So what I mean by that, we'll look at individual variables first, specifically other categorical variables, and then for the bivariate analysis, we'll look at numerical variables and how they correlate or do not correlate with bounty. So the first plot we have is our blood plot, conveniently put in red, and we can see that the highest counts of characters by blood type is F, X, and S, followed by XF and unknown, and then a rare blood type of character bounties have with S or H. I thought that was something that would be super interesting, but it's actually not. And what I mean by that, so in our next visual, we'll look at the average bounty by blood type, and you can see that F dominates the list. So one interesting insight or tidbit is that 4 out of 6 Yonko and 3 out of the 4 current Yonko have blood type F. So the 4 out of the 6, that includes Whitebeard, that includes Kaido, Luffy, and Buggy the Clown. The 2 Yonko that aren't in that are Charlotte Linlin, the only female, and Shanks. Special blood maybe? I don't know. But yeah, so we can see kind of blood types F have the highest, followed by XF actually is the second highest, then blood type S, SRH, X, and unknown. Another interesting character that had blood type, if you remember in Fishman Island arc, we had a very big moment between Luffy and Jinbei. So Jinbei has blood type F. They were noted to have the same blood type, which is why Luffy was able to have that transfusion and save him. That was actually a great moment if you think about it. So, nice. The next plot we'll look at is another kind of blood. We're going to use what's called a box plot, and we'll look at blood type in another fashion. But basically, you can see F has the highest ranges, and then of course it has the most amount of outliers in terms of bounty. So in the S blood type, we have Roger, and then we have Mihawk. We also have some other interesting characters like Crocodile, Bo Hancock, and King. They're all in this blood type. But yeah, I thought this was kind of interesting to see the outliers. You can see most of the heavy hitters are in the F, and then followed by S as well. And yeah, so that's a nice little visual. Moving forward, we take a look at the origin. Most of the characters with bounties come from the Grand Line, followed by the East Blue, Unknown, South Blue, North Blue, West Blue, Combo, and then some other islands. Tibet is Panda Man. Panda Man apparently has a bounty I wasn't really aware of. But yeah, then we have Sky Island and Red Line. Then we do the same thing, kind of, where we look at the averages. I didn't do a chart because the name was kind of blurring the text, but basically you can see the average by island, East Blue having the highest overall average, followed by the Grand Line, and then we have North Blue, kind of a couple of different, then the Red Line, and then all the other areas. But that's good to know that the Straw Hats are carrying the East Blue in terms of bounty averages. Now we're going to run through really quickly some bivariate analysis and see if there's any relationship between fields and bounty. So the first thing we'll look at is putting the bounty on the y-axis, and then we look at chapter appearances. So this chart is pretty easy to tell who this group is. The main character appearing the most, so that's Straw Hat Luffy, and then we have the second main character, no last name Nami. And then we have Zoro and Sanji really close together here in bounty and chapter appearances, but Zoro is edging out Sanji just enough. And then we have all the other Straw Hats kind of filling in here. So this is kind of hard to discern. Obviously we know that this is Roger, and then this is Whitebeard, and then Kaido, I believe, and Big Mom. You can just tell who it is by ranking. So this this chart doesn't necessarily show too crazy of a relationship, but maybe that's because these guys are stretching it out. Next thing we'll look at is at the age and bounty. So we know we have Morley over here. This I think is a little bit more relationship shown. If Morley wasn't there, this line would be much higher up and kind of fitted to this a little bit better. So he's definitely an outlier. We have kind of our intercept being Bonnie, the youngest character with a bounty. Two other characters here that are older but not so much of a high bounty. This includes characters like Brooke, who comes in around 90 years old, and then we also have characters like Chinjiao as well as Orange Jr., high age, not super high bounties. Then we have a character like Lao Ji here. Of course, we have the former generation. Again, we could always start with the top being Roger, followed by Whitebeard. Then we have Lin Lin, Kaido. Over here, you kind of have the new gen, Yonko, Shanks and Blackbeard neck and neck. Then you have the worst generation right here, and then you have some middle filler characters like Buggy, and then of course Yonko Mihawk. So that's the age by bounty plot. I do think there's a little bit more relationship here. Naturally, I think that makes sense. The older you are, the longer you've probably been a pirate. You've had more time to develop your reputation amongst the pirate world. But naturally, you're going to have some kind of outliers that pull down the general relationship. Now we move on to our final scatter plot, which is going to plot the height by bounty. This one, there's probably actually the least amount of relationship here. We have Horse Jr., substantially stretching out the plot over here. He takes the cake in terms of height. And then you kind of just have two clusters. You kind of have like the old gen characters, and then everybody else here. So not too much of a relationship. And that's going to conclude part 1 of our bounty analysis. I hope you enjoyed some of the insights and visuals that we uncovered here. Stay tuned, I have 2 more parts coming. The second part's going to be where we dip our toes into some unsupervised machine learning, taking all these variables and seeing if we can look at them, find different patterns outside of just univariate and bivariate analysis. And then part 3, we're going to see how good our future state observation hockey is and actually try to predict some of the characters' bounties. I think I have some interesting use cases there, and we'll see how that turns out. If you've enjoyed the content, remember to like and subscribe to stay tuned for more awesome anime analytics videos presented to you by Taicho and of course X. Till next time, Taicho out.